Hi guys, welcome to our lesson. So we are going to look at quadratic functions, right? What are they? How do we draw them? How do we find the equations for quadratic equations? Those are the things that we're going to try and be focusing on. How do we transform them and move them around and play around with them? What exactly does that do to the function? That's really what we're gonna please do right now. But let's just jump right into it. Firstly, the first type of function we're going to look at is the quadratic function, which is a function of the form y is equals to ax squared plus q. Now, so the a and the q are normally constants. Remember, every function needs to be drawn on a Cartesian plane which has x and y. So that's why the y and the x are always there. You don't change them. But what we don't need is the a and the q. So that's why I'm saying these are constants, meaning they are actual values, right? So a can be any real number, q can be any real number. And then the graph of a quadratic function is normally called a parabola, right? So this is called a parabola, which we will look at the shape of it just now. Firstly, I want you to consider the graph of f of x is equals to x squared. Remember, the f of x is my output values. This is the output, and the x value will be the input value, right? So that's why I only give you the x values. I want you to find the f of x. So when x is minus 2, the value of f of x is going to be minus 2 all squared, which will give me a positive 4. When x is minus 1, it will be negative 1 all squared, which will give me positive 1. When it's 0, it will be 0 squared, which is equals to 0. And then 1, it will be 1 all squared is equals to 1. And then when it's 2, it will be 2 squared is equals to 4. Now, just to make a note about this as well, I know even sometimes we think we only need brackets when it's a negative value, but just so that you get used to it, please include brackets, whether it's negative or positive that you are substituting. Just use brackets at all times, so that even when you have forgotten that you must use brackets, it is just conditioned to you that whether it's positive or negative, I must have brackets. So you won't suffer from these things of making these clumsy mistakes that we make, where if it's a negative and then someone does not include brackets, it won't give you a positive answer in terms of when you press a calculator, right? So what I really mean is, if you say minus 2 squared and press this on your calculator, I promise you, it will not give you a positive 4. It will give you a negative 4, which is something different from what we need to look at. So please, this you must not do at all times. You must make sure that you include your brackets. Now, the graph is normally obtained by plotting the points on a Cartesian plane and drawing a curve through those particular points. Remember our points, this is supposed to be 4 there, just not 1. So if that is 4, that is 1, that is 0, 1, and 4. It means, firstly, I will start with minus 2. From minus 2, you know it's 0. You move 2 units to the left. At minus 2, you move 4 units up. So it will land you at this particular point there. And then minus 1, you move 1 unit up. It will land you at that point. 0 with 0, 1 with a positive 1, 2 with a positive 4. And then you just join these points like this, right? So you just join them, and then it will give you a curve like that, right? So at the end, we normally indicate the end of the graph with an arrow to show that this is actually going to continue indefinitely. We just used few values here, not all of them, right? Because remember, a number line continues up until positive and negative infinity. If you draw it up to scale, it will look like this, which is more or less the same as what I just showed you now. Now, all output values are positive. Why are they positive? Because of the squared that I have there. So you can see all the output values is positive. 1 is 0, 2 there if I want to use it, 3 there, and there's a 4 there, and then you know there will be a 5 there. So all the output values will all be positive. And then the graph, we call it a parabola. So this is called a parabola. Right, so you need to, why we call it this is because we're not going to be using the word quadratic function going forward. It will be draw the following parabola or analyze the following parabola. So that's the word we are going to be using going forward. Now, the domain of the graph is normally given by x is an element of real numbers. Why I'm saying this is because the x squared makes it a point that all the x values that are on a number line, because they are real values, they are all defined, they are all valid on this particular graph, right? So that's why the domain will be x is an element of real numbers. Remember, domain is a set of all the input values where the graph is defined. So it means on the number line of the x-axis, whether you go to positive infinity or negative infinity, all the numbers are defined. They are all valid. But with a range, we then need to limit this, right? Remember we said all the output values are positive. So it means all the output values are, number 1, greater than the 0, meaning they are positive. Number 2, they also include the 0 itself. So I will say the range is y is greater or equal to 0. This simply means that 0 is part of the y values, and then anything else that is positive will also be part of the y values. Now, also, I know that maybe some of us, it might be the first time we're seeing the letter element of. Element of would just mean a set of all these values that are there. And then this is also normally written as y is an element of. Remember we said 0 is part of this, so I will have 0 there, a semicolon, and then I say this is to infinity. And then you leave it like that. Why this is a square bracket is because 0 is part of the answers. You always start with a small number and go to the biggest number. And the biggest number here is infinity, which we do not know. Now, when we talk about the shape of a parabola, the value of a, right, in this equation, the general equation, determines the closeness of the arms of the parabola to the y-axis. So you do need to understand this, right? So it means if a maybe is small, it will be this particular close, and then if it's big, you'll find that it's a bit wider like that, right, from the y-axis. I know I'm not drawing it to scale, but it gives you an idea of what we really mean. The larger the value, the closer the arms are to the y-axis. So if it's 2x squared compared to 4x squared, this will be a bit wider and this will be a bit close. So this will be maybe something of this nature, and then if it's 4, it will be a bit closer now to the y-axis. So the arms will be a bit closer to the y-axis. And then the sign of A will cause what we call a reflection in the x-axis. Now, we normally use the word happy face and sad face, right? And I will show you why we say that. If A is a positive, the parabola is called a concave up, which we say is a happy face. Why it's a happy face? It's because it is forming a smile, right? So it's a curve that is facing up like this. So it is forming a smile, which is a happy face. So that's why we are saying it's a happy face, just for you to understand and see it visually with your eyes, right? Then, when it is less than 0, it is normally said to be concave down, which we say is a sad face, right? So it will be facing that way. Now, we also have what we call the turning point, right? The turning point is where the graph is going to change direction, right? So it is where it is going to turn, as the word itself says, turning point. It means that it's where, so the graph will go, it will get somewhere where it curves a bit, and then it changes direction, and now it goes up like that. So the turning point will be where it is just turning to change the direction. Normally when A is positive, meaning greater than 0, the turning point is normally said to be the minimum, and then when it is concave down, which is a set face, the turning point is said to be a maximum, because that's the highest point of the graph. Now, in specific, to look at the changing of parameters, we're going to focus mainly on the quadratic function, which is normally called a parabola. So remember that a quadratic function is a function of the form f of x is equals to ax squared plus bx plus c, where the a, the b, and the c are constants, right? They can be any real number that is there in mathematics. They don't represent anything specific. And then the graph of a quadratic function is normally called a parabola. Also, the quadratic function can also be in the form f of x is equals to a open bracket x plus p all squared plus q, right? Where the p and the q are the coordinates of the turning point. So in simple terms, if you know what your turning point is, your very first thought will be to look at this particular equation in order to maybe find the equation of that particular graph, or to then actually tell what the turning point of the graph is. But with the other one, it will be mainly when we want to talk about the root, which are the x-intercepts, which I believe by now you do know that x-intercept will mean we must let y be equal to 0. And then we can solve for x from there. So that's what this is all about. So this is the other type of a quadratic equation that we can use to represent a parabola, given that we know what its turning point is. Now, the value of a in the equation, because we still need to know what exactly this a tells us, right? The others are constants, yes. Even a is a constant, but it tells us what the orientation of the graph is, and it also tells us the closeness of the arms of the parabola to the y-axis. In actuality, it means that if my a is greater than 0, meaning it's positive, right? Therefore, the parabola will then be concave up, which we use a happy face as a representation, or rather as an explanation of what this is, because it is looking like a happy face, a smile. And then when a is less than 0, the parabola will be concave down, which then means it's a sad face. So just so that you can remember what it looks like. Remember, I said again, it also talks about how close it is to the y-axis. So the greater the value of a, the narrower the graph becomes. In simple terms, the more close it gets to the y-axis. Just to show you what this means, if maybe my graph is y is equals to x squared, it will look like this, and then it becomes 2x squared, and then it becomes 3x squared. So as a is increasing, it means that the graph will become a bit narrower in terms of the distance from the y-axis. Just so that we can look at a specific question now of this, how do we change these parameters? The first question will want us to draw a graph of f of x is equals to x squared. And then we'll go down with the questions to see what it will end up as at the end. To draw the graph, remember that the very first thing to always try and do is to find the table of values, right? Where you choose your own inputs, but the input, if you take from -2, you can take up until +2, and then find the output values using the equation f of x is equals to x squared. And then after drawing the graph, it will therefore look like a happy face number 1, because the value of a is equals to 1, and that's a positive, so it must be concave up. And then because it is x squared, it means all the output values will definitely be positive. We then need to reflect this about the x-axis, and to do that, it means that because the function was f of x is equals to x squared, when I reflect this about the x-axis, it will be minus f of x is equals to x squared, which eventually becomes f of x is equals to negative x squared. So in simple terms, it now becomes a sad face instead of the happy face. And therefore the graph will look like this. And then you will also need to shift the graph 1 unit left and 3 units up. So just to go back to what we had, right? Remember that the graph was turning at 0 and 0. Firstly, you shifted 1 unit to the left. So it means it will now be turning at -1 and 0. And then after doing that, you shifted 3 units up. So it will be at -1 and 3. Therefore, my turning point will be at that point there. Now, they will also want us to write the equation of the new function. To do that, you need to look at how did we form g of x. We formed g of x by reflecting the graph of f about the x-axis, which made it to be negative x squared. And then from there we shifted it 1 unit left, and shifting it 1 unit left will make it negative x plus 1 all squared, and then we shifted this 3 units up, which will mean it will be plus 3. Now I know some people are going to wonder why is it plus 1 and not -1, because to the left is minus. But it simply means that its y is equals to -1, right? Because x is equals to -1, that's where it lands. So the new turning point will be x equals to -1. If I want to write it as x plus p, it will be x. Then the -1 is taken to the other side, therefore it becomes +1 equal to 0. That's where the +1 comes from. And therefore, my equation will then be g of x is equals to minus into x plus 1 all squared plus 3. Just to summarize what we know about these two functions, the value of a for f of x was 1, and the value of a for g of x is now -1, right? Because it was reflected about the x-axis. The turning point was at 0 and 0 for the graph of f of x, and now for the graph of g of x, it was moved 1 unit to the left, so the x value is now -1, and it was shifted 3 units up, so the y value is now +3. And the domain is x is an element of real numbers because it can be any number because of the squared, and it does not change even with the g of x. But what changes is the range. Here with this graph, remember it was above the x-axis, so it means all the y values are positive, and this one will then be less than 3 because that's where it will be tending to face down. So that's what you need to look at. When you are shifting a graph, you just need to look at what will be the new value. That's what will inform you to write the new formula.